Hello students, so today we'll go further of the function part. In the last exercise we understood what is domain, what is range, what is codomain of the function, how to understand the mapping diagram of a function. And now today we will understand how to find the domain of the function and for which kind of function you have to consider some conditions. Okay, the very first thing is you have to understand the graph of a function also. That means if any graph is there, then how are you supposed to say that okay, this is acceptable graph of a function? Okay, so there is a trick which is called vertical line trick. I'll explain you. Let's say the graph of function f1x is of this kind and the graph of the function f2x is of this kind. Okay, now if you want to understand whether this is any one of the function is called function or not, that means whether this is a function or this is a function or not, then you have to just see the vertical line. That means you are supposed to understand, or you are just supposed to see that when you are drawing the vertical line of the graph, then there should be only one intersection point has to become. See, you if you are seeing here, there are only one intersection point. Okay, but in this graph, when you are drawing the vertical line, if you understand, there are two intersection point are coming. If any one vertical line is giving you two intersection point of the graph, then you are supposed to say that this is not a function. Let's take one more example. Let's say my graph of the function is of this kind. Okay, now what will happen here? You are drawing vertical line, one intersection point, one intersection point, one intersection point, but in this places you are getting two intersection point, or somewhere you are getting three intersection point, then you are supposed to say that this is not the graph of a function. Okay, now the next thing is domain of the function and how to find the domain of the function. Okay, the very first thing is, before starting with the domain of the function, the thing that needs to be clear is, if I'm talking about any polynomial function, if I am talking about any polynomial function, I hope you understand what is polynomial function. Fx is equals to of this kind, a n x raised to the power n plus a n minus 1 x raised to the power n minus 1 plus and so on, plus a1x plus a naught. I hope you remember, we studied in 10th class. Okay, that means for an example, if fx is equal to x square, or fx is equal to x, or fx is equals to x square minus x plus 1, or fx is equals to x raised to the power 6 plus x raised to the power 5 minus 3x, these all are called polynomial function. I hope you remember. Okay, if you forgot, then you can just go through your 10th class and you just understand what are called polynomial function. Okay, so for all kind of polynomial function, domain of the function will be always R. What is R? Real numbers. Okay, so whenever the polynomial function is given, don't use your mind, you just remember that for any kind of polynomial function, the domain of the function will be always R. Okay, now further we'll go of the function of this kind when some function f1x upon f2x is given. That means one function is in the numerator and another function is in the denominator. Okay, for these kind of function, the domain of function f will be the intersection of domain of f1x intersection domain of f2x minus the point at which f2x is giving you 0 value. I hope you understand. This is a kind of function fx where some expression is in the numerator and some expression is in the denominator. Okay, so for that function, if you want to find the domain of that function, what you are supposed to do, you just find the domain of f1x, find the domain of f2x, take the intersection of both and subtract the value at which the denominator is giving you 0 value. Okay, so let's take one example. If fx is equal to x minus 1 upon x square minus 9, let's say this is your question. Okay, the question is, find the domain of fx. Okay, so again understand, fx is equal to x minus 1 upon x square minus 9. I'm just considering this as f1x, it is a one kind of function, and this is f2x, this is another kind of function. Okay, if I'll ask you f1x is equal to x minus 1, which kind of function it is? Again, this is a polynomial function. If it is a polynomial function, then domain of f1x will be our real numbers. Okay, in the same way, f2x is also a polynomial function. This is also a polynomial function. So domain of f2x will be r again. Okay, so I hope in the second point what I told you, when fx is equal to f1x upon f2x, then the domain of f will be intersection of both the domains, that means r intersection r, minus when f2x is giving you 0 value. Okay, so you just put f2x is equal to 0, that means x square minus 9 is equals to 0. Factorize it with the help of a square minus b square, you will be getting x minus 3 into x plus 3, which is equal to 0. So you got x is equals to minus 3 and x is equals to 3. Okay, so from here, from here you can say that the domain of the function will be r intersection r minus, subtract these two values. Okay, now if I'll ask you, I hope you remember what does it mean by intersection. Intersection means we are finding the common values. Okay, so what is the intersection of r intersection r? You are taking the intersection with the same numbers, that means the value will be r. So real numbers minus, you are subtracting minus 3 and 3. So this is the domain of function f. Now you again go back to your question. You are saying that this function is accepting all the values except minus 3 and 3. Why is it? Because if you are putting minus 3 in the denominator, minus 3 square is giving you 9. 9 minus 9 will be 0, and something upon 0 will be giving you infinite value, which is not acceptable for the function. Okay, so I hope this is clear. So whenever these kind of questions are given, you are supposed to do this trick. Okay, let's take one more example. Let's say if I'll ask you fx, example, fx is equal to 2x upon x square minus 9. You can just pause the video and you can try on your own, and then you can tell me the answer. Okay, so instead of 9, you can just make it 3. Okay, so just check your answer. The answer will be r minus root 3. You just try, and if you are not understanding how I find it, you can ask me in your comment section. Okay, next example is fx is equal to, again you have to find the domain of fx. Okay, next is x square minus 4 upon x into x minus 2. Okay, just find out the domain of the function by pausing the video. But if you want to understand, again fx is equals to x square minus 4 upon x into x minus 2. This is a polynomial function, so domain for this is r. This is again a polynomial function because it is giving you, after multiplication, what it will give you? X square minus 2x, again polynomial function. So domain for this function will be r. Okay, so the domain of f will be r intersection r minus the points at which this denominator is 0. That means x into x minus 2 is equals to 0. So x is equals to 0 and 2. So you have to exclude these two values. So the domain of function f will be r minus 0, 2. I hope this is clear. There should be no doubt because this is the simplest examples of finding the domain of the function. Okay, so we already understood of two kind of function. Now we are going to go to the third kind of function. That means if y is equals to under root fx is given, that means under root something, some expression is given, then for that, if you want to find the domain of that function will be fx will be greater than equal to 0. That means you just have to write down the condition fx will be greater than equals to 0 and find the value of x, that x will be the domain of the function. That means the value of x at which fx is greater than equal to 0. Why is it? Because inside the under root there it cannot accept the negative value. That means it can accept either 0 or positive values. Okay, so let's take one example. Let's say fx is equal to under root x square minus 5x plus 6. Let's say this is your question. Okay, and you just have to find the domain of fx. Now I hope you understand that this is your function. Sorry, you can just remove this. Okay, y is equals to this. Okay, so I hope you understand that this is a kind of function y is equals to under root fx. Okay, that means whatever is inside the under root, x square minus 5x plus 6 should be equals to greater than equals to 0. Okay, now I hope you understand how to solve the inequality. Okay, so for that, to solve the inequality you have to factorize it first. Okay, so I'm just using the middle term splitting. The multiplication needs to be 6 and addition and subtraction needs to be 5. So after doing the middle term splitting, it will be minus 3x minus 2x plus 6 should be greater than equals to 0. That means x minus 3 into x minus 2 should be greater than equals to 0. Okay, so to solve these kind of inequality, I hope you remember we draw the number line first and then you are supposed to mark the critical points. That means 2 and 3. Okay, because this is the number line, so 2 will be here and 3 will be here, and after that the rightmost will be assigned with a positive sign, then negative, then positive. But you want greater than equals to 0. That means greater than equals to 0 means it should be positive. So you just have to select the point where it is giving you greater than equals to 0. So where you are seeing the positive sign, that will be your solution. That means from here to here and then from here to here will be your final answer. So what is the domain of the domain of y? Your answer will be minus infinite to 2 including union 3 to infinite. Okay, again why I am including 3 and 2? Because here the inequality sign is having equal to sign, greater than equal to. If it would have been only greater than, then you have to exclude 2 and 3. Okay, I hope this is clear. Let's take one more example. Y is equals to under root x square minus 4 upon x minus 5. Okay, so by seeing the question, you just don't get afraid that how to solve these kind of questions. This is very difficult. It is not difficult, it is very easy. Okay, so how to solve this kind of question? You just remember what are the rules I told you. Whatever is inside the under root, that thing needs to be greater than equals to 0. You just go step by step and then you will understand. That means inside the under root needs to be greater than equals to 0. So x square minus 4 upon x minus 5 needs to be greater than equals to 0. Correct? Now again you need to understand how to solve the inequality. So first factorize it. In the numerator it will be x minus 2 into x plus 2 upon x minus 5 should be greater than equals to 0. Okay, again draw the number line. Just find the critical points. What are the critical points? Minus 2, 2 and 5. Okay, so I'm just marking the critical points minus 2, 2 and 5. Okay, again assign the rightmost with the positive sign, then negative, then positive and then negative. You want greater than equals to 0. That means you want positive or negative? You want positive. So positive sign will be your solution, this and this portion. Again I have included minus 2, 2 and 5. Why? Because equal to sign is there. Okay, so what is the domain of y? Your answer will be wherever you are seeing the positive sign. That means minus 2 to 2 union 5 to infinite. I hope this is clear. Okay, if you have any doubt how to solve the inequality, you can ask me in the comment section. Okay, let's take one more example. Fx is equal to under root 2x plus 3 plus under root 3 minus x square upon x. Okay, again, by seeing the question, I'm sure that you will be afraid that how to solve this kind of question. Okay, again, I'm telling you it is very easy. Why it is easy? I'm just splitting this question into two parts. How two parts? I'm just considering this is my one of the function f1x and this is my another function f2x. Okay, if I will give you only this function, f1x will be under root 2x plus 3. If I'll ask you, can you find the domain of the function? Yes, we can find. Why? Because inside the under root, whatever the expression is given, that needs to be greater than equals to 0. This is the rule of that kind of function. Okay, so if you want to find the domain of f1x, you have to tell that 2x plus 3 needs to be greater than equals to 0. That means 2x will be greater than equals to minus 3, x will be greater than equals to minus 3 by 2. Okay, so you are supposed to say that the domain of f1x will be greater than equal to minus 3 by 2 means minus 3 by 2 to infinite. Clear? Now I am finding the domain of f2x. What is the function f2x? Under root 3 minus x square upon x. Again, what should be your answer? Whatever is inside the under root, that should be greater than equals to 0. Now you have to remember the inequality, okay? Because whenever we are solving the inequality, that x square coefficient or x coefficient needs to be positive. So first make it positive. If you want to make it positive, the inequality sign will be reversed. That means you are going to multiply with the negative sign on the both side, okay? So it becomes x square minus 3 upon x and just reverse the inequality sign. That means less than equal to 0. Now we are going to factorize it. X minus root 3 into x plus root 3 upon x should be less than equal to 0. Okay, again find the critical points. What are the critical points? 0, minus root 3 and plus root 3. Assign the sign positive, negative, positive, negative. You want less than equals to 0. That means you want a negative sign will be your solution. So your solution will be from here to here and then from here to here. Clear? Okay, one more mistake we did here is this 5 has to be excluded. Why excluded? Because 5 is in the denominator and denominator cannot be 0. Okay, in the same way here also the denominator cannot accept a 0 value, so it will be not acceptable. So what is the domain of f2x? Your answer will be minus infinite to minus root 3 including union 0 to root 3. Okay, now you got the domain of f1x and domain of f2x. Now understand one more concept. Your fx function is combining f1x plus f2x. Okay, so the domain of f will be intersection of f1x and f2x. That means intersection of domain of f1x and domain of f2x. So if I'll ask you the domain of f1x and find the intersection of domain of f1x and domain of f2x, what is the domain of f1x? The domain of f1x is minus 3 by 2 to infinite intersection minus infinite minus root 3 union 0 to root 3. Okay, so by just seeing this, it is very difficult to find the intersection. So what we'll do is we are going to draw the number line. Just mark the points. Okay, minus root 3, where it will come? Here somewhere. Minus root 3 is here. Minus 3 by 2 will be approximate minus 1.5, right? So it will be here somewhere. 0 is also one of the point and root 3 is also one of the point. Okay, now you just apply the solution here. Minus 3 by 2 to infinitive. That means I'm talking about this solution. Okay, the next is union of both this. Minus infinite to minus root 3. So it will be from here to here. Excluding or including? It is including and this is also including. So it will be here. You just mark it just above this line. Okay, and then 0 to root 3. So from here to here. Now you just mark the point where you are seeing the two lines. So your answer will be 0 to root 3. I hope you understand what we did here. Again, see, this is fx. You are seeing two different kind of functions are given and they are adding. Okay, so this needs to be very clear. Is this is a one kind of function f1x, this is a another kind of function f2x. Find the domain of f1x, find the domain of f2x, because f1x is a kind of function of under root. That means whatever is inside the under root, that needs to be greater than equals to 0. In the same way, for f2x also the same thing will apply. Okay, after getting the solution for domain of f1x and domain of f2x, you just understand that you have to remember how to solve the inequality part. Okay, here what will happen, the x square is having negative sign, so we just make it positive by multiplying with the negative sign. So whenever you are multiplying with the negative sign, the inequality sign will be reversed. Okay, after that, after solving the inequality by drawing on the number line the critical points, we got the domain of f2x. Now the domain of f will be the intersection of domain f1x and domain of f2x. This is the rule to find the domain of any kind of function. Okay, whenever two different functions are adding or two different functions are subtracting, the domain of the whole function will be intersection of both the domains. Okay, so now what is the domain of the function? The intersection of this and this. Okay, so to find the intersection of this, we draw the number line. Okay, so I just draw the number line. One solution is minus 3 by 2 to infinite, so I just mark minus 1 by 3 to infinite. And then after that, this is also a solution of f2x, so I just considered this the solution for f2x just above this line. Okay, you are not supposed to combine both the lines. So wherever you are finding two lines, okay, why two lines? Because this is the domain of f1x, this is the domain of f2x, so you will be getting two lines. Okay, because you are taking intersection. So wherever you are getting two lines, that will be your final solution. So you are getting the two lines here from here to here, that means 0 to root 3 will be the domain of function f. Okay, let's take one more example. fx is equal to under root 2 minus x minus 1 upon under root 9 minus x square. Okay, I want you to solve this question. One more example is fx is equal to under root 3 minus 2x minus x square. You just try these two questions. If you are able to do, then it will be good. If you are not able to do, then I'll help you. Okay, so the second question will be very easy for you. I'm just going to give you a hint. Find the domain of the function. How to find? Whatever is inside the under root, that should be greater than equals to 0. Okay, after applying the greater than equals to 0, you know that x square coefficient is negative, so you have to multiply with the negative sign, and then inequality sign will be reversed. Factorize it, and then just draw the number line, find the critical points, and then plus minus plus, and then you are able to find the solution. Okay, and for the first question, you have to divide this into two parts. This one is f1x, another is f2x. f1x is having domain, it is very easy to find the domain of f1x, but for f2x, you understand that something upon denominator is there, so denominator needs not to be equal to 0. So whatever is inside the under root, that should be greater than 0, not greater than equals to 0. That's it. Okay, that means 9 minus x square has to be greater than 0, not greater than equal to 0, because if you are applying greater equal to 0, then the denominator will be 0 and it is approaching to infinite, which is not acceptable for the function. Okay, that means 9 minus x square will be greater than 0. Okay, it is not greater than equal to 0. So after applying again 9 minus x square is greater than 0, again you have to multiply with the negative sign and inequality sign will be reversed, and again you have to solve, draw the number line, and then do the same process. Okay, I'll discuss these two questions in the next class. Till now you just try and solve this question. Okay.